Okay, so hopefully you moved your chapter 5 into your OneNote from the content library. Today we're going to do 5.1 linear systems of two variables. Many of you all have done this in Algebra 2 multiple times. The first example says solve by graphing. I'm going to go ahead and number my equations 1 and 2. I'm going to put my equation into the form y equals mx plus b. So for the first equation, I'm going to have 2y equals negative 3x plus 9. Divide each term by 2, and I get y equals negative 3 over 2x plus 9 over 2. My second equation, I'll have 5y equals negative 2x minus 5. So I'm going ahead and moving that 2x over. Divide each term by 5. And I have y equals negative 2 over 5x minus 1. So these are the two equations that I am going to graph. Okay, so I'm going to graph the first one. I'll do the first one in red. Oops. And we'll go ahead and graph the y-intercept, which is 9 divided by 2, which is positive 4.5. So 1, 2, 3, 4, 5. So right about there is 4.5. From there we go down 3. So 1, 2, 3 over 2. 1, 2. Down 3. 1, 2, 3 over 1, 2. And then we get the line of the first graph. Then we do the second one, which I'll do in green. Our second equation is negative 1, so we'll graph at negative 1. And then I'll go down 1, 2 over 1, 2, 3, 4, 5. And my graph is going to do something like this. And so we have an intersection point. Of course, my red graph is not exactly accurate, but oops, the red graph would cross right through that point there. So the point that they have intersection would be the value of this point in black. So our solution to the graph would be down, or sorry, to the left, right, 1, 2, 3, 4, 5, and down 1, 2, 3, so negative 3. So this should be the solution to our graph. So substitution method, many of you all have done this before. You want to isolate one variable or term that appears in both equations, substitute into the other equation, then solve for the remaining variable, back substitution, and solve for the other variable. Write the answer as a point. This time we're going to solve by substitution. I'm going to number my equations 1 and 2. And I'm going to use equation 2 to substitute to equation 1. So what I'm going to do with the equation 2 is go ahead and solve for x. So if I do so, I will have negative 7. Just kind of rewrite this. So you have 2x minus 7y equals 3. The goal is to get x by itself, so I'm going to add 7y to both sides. That gives me 2x equals 3 plus 7y. I'm going to divide by 2 for each term. That gives me x equals 3 halves plus 7y over 2. So this is what I'm going to substitute in for x into this first equation. So now I'm going to do my substitution portion. I'm going to substitute this x in for this x, which will give me 3 times 3 over 2 plus 7y over 2 plus 5y equals 2. From here, I can go ahead and solve for the variable in common, which is y. I'm going to distribute the 3 to both terms, and I get 9 over 2 plus 21 over 2, 21y over 2 plus 5y equals 2. Sorry about that. Okay, so we're going to go ahead and subtract the 9 halves from both sides. So I'll do that over here. We have 2 minus 9 over 2. So find a common, make a common denominator by multiplying top and bottom by 2. So we get 4 over 2 minus 9 over 2, which equals 5 over 2. So we have 21y over 2 plus 5y equals, that should be a negative 5 over 2. Now the idea is to get this y by itself. So we want to solve for y in this case. So by solving for y, we can go ahead and combine these. If we put this over 1, multiply this by 2, and 2 top and bottom, so we have common denominators. We'll have 21y plus 10y over 2 equals negative 5 over 2. And that gives me 31y over 2 equals negative 5 over 2, which I can take the reciprocal by multiplying both sides by 2 over 31, just so I can get the y by itself. So I get y equals, that cancels and becomes 1. So we have negative 5 over 31 for y. Y value, now we need to find the x value. So we can use the fact that we had this equation, we rewrote equation 2, solving for x. We can take the y of negative 5 over 31 and substitute it in for y. And I'll go ahead and write, so we'll write this in green. So we have x equals 3 over 2 plus 7 over 2. Our y value is negative 5 over 31. So I can go ahead and simplify this to be 3 over 2 plus negative, or we can go ahead and change that plus sign to minus, negative 35 over 31 times 2 gives 62. So then we have to find common denominators and multiply these two things. If we simplify this, we'll get 58 over 62, which reduces down to 29 over 31. So when we write this, remember this is our x value. So x equals 29 over 31. So our solution to this is 29 over 31, comma, negative 5 over 31. That is your final solution. Elimination method. We multiply each equation by a constant in order to get the LCM as the coefficient of one variable. Getting opposites makes it easier. Add the equations in order to eliminate a variable. Then solve for the remaining variables. You use back substitution and solve or eliminate the other variables. At the end, write the point. So we're going to solve by elimination for this one. And I notice here that I have the two equations, which I'll write off here to the side, numbering them 1 and 2. So first equation, 3x plus 5y equals 2, and 2x minus 7y equals 3. So I'm using the elimination method, which because I noticed that these two signs are already opposite, I'm going to try to use the idea of getting rid of and eliminating y. So I'm going to multiply this entire equation by 7 because I know that If I multiply 7 times 5, that'll give me the 35, a positive 35. And if I multiply the second equation by 5, that'll give me a negative 35, which will help me to eliminate the y value. So from here, I'm going to go ahead and rewrite it as if I multiply everything by 7. So I have 21x plus 35y equals 14. The second equation reads 10x minus 35y equals 15. So I can take the two equations, 21x plus 35y equals 14, and add it to 10x minus 35y equals 15. So if I add the two, I get 31x, these two will cancel, equals 29. Solving for x, I divide by 31 on both sides. X is going to equal 29 over 31. Now I have to identify what is the y value. So I can choose whichever equation I would like to substitute for y. So I'm going to go ahead and choose, let's say, I'll choose the first equation. I'll do that in green. So I'm going to substitute for x. So I have 3 times 29 over 31 plus 5y equals 2. So from here, I need to identify first what happens when I multiply 29 times 3. It doesn't divide evenly with 31. That gives me 87 over 31 plus 5y equals 2. So then I'll subtract 81 over 31 from both sides. That'll give me the 5y equals, give me a second for that one. Okay, so sorry there's a typo there. This should be 87, not 81. So 87 over 31. We'll change this value here. 87 over 31. That gave me 25 over 31. And so if I go ahead and simplify this to be solving for the value of y, I would go ahead and multiply both sides by 1 over 5. Let's get rid of that 5, and it'll give me y equals, that cancels to 1, this becomes 5, and I get y equals 5 over 31. Sorry about that, so negative 5 over 31 is your y value, which means your x and y ordered pair for the solution, your x is 29 over 31, comma, negative 5 over 31.